Welcome back, everybody. This video we're going to be talking about function translation. It's worth it to point out just f of x. We have function could be anything. We're going to focus on quadratics, but f of x can be absolutely any function. In this case, and the examples today, regular quadratic functions. If you add a number to the function, you'll translate it up that many units. If you subtract a number from the function, you will translate it down that many units. Now this kind of makes sense, positive up, negative down, especially when dealing with the y-axis. But on the x-axis, it's kind of the opposite. When you see f of x plus h, you're translating it to the left h units. If you see f of x minus h, you're translating the function to the right h units. So positive left, negative h when translating horizontally. You can multiply the function by a. And if a is greater than 1, then you stretch f of x by a factor of a. It kind of gets skinnier. However, if a is less than 1, it's going to compress the function and make it wider with respect to the x-axis. So let's look at a few examples and see how these work. First one, how would you describe the transformation of f of x equals x squared minus 1 to get g of x, which is x plus 2 squared minus 1. Looking at these two functions, the only thing difference is on the inside. X is being added to 2 on the inside. So since it's on the sort of the inside right next to x, that tells us a horizontal translation is taking place. And since we have the original g of x is the original f of x, but it looks like we just added 2 to it. It's f of x, but we added 2. And if you remember our chart from before, if I add 2, that means I'm going to the left 2 units. Let's look at another one here. Alright, the quadratic function f of x equals 2x squared minus a is translated 2 units down. What's the new function simplified? So we have f of x, and we're going down 2 units. So that means we subtract 2 from the whole function. Well, here's the function, 2x squared minus 8. But then from that, I'm taking minus 2 away. So I'm now going to have 2x squared minus 10. And that is our new function. Whether we call it f of x or g of x or whatever, that's what the new function looks like. Next one. F of x equals 1/2 x squared plus 4 is stretched vertically by a factor of 4. What's the new function g of x simplified? Alright, so g of x is I take f of x and I vertically stretch it by a factor of 4. That means I just multiply it times 4. 4, and then the function is 1/2 x squared plus 4. 4 times 1/2 is 2. 2x squared plus 16. That's what the new g of x function is if we stretch it out. Alright, and you can see that difference if you were to graph the original 1/2 x squared plus 4. You can do that on Desmos. Then you can compare it to this, have this on the same graph. You'll see the difference. Here we're given a graph of 2 functions, one translated from the other. It says g of x, right here, here's g of x, transformation of f of x, which is x squared. What is the equation? Well, g of x and f of x look like the exact same function, but g of x just looks like it was translated 2 units up. They shifted it up. Yeah, so g of x, we take f of x, and it looks like it just went up 2 units. So what is g of x now? It's the f of x function, x squared, and then we just add 2 to it. That's what g of x is. And then finally, we want to look at these two. We just want to graph both of these. So before we graph, we'll look at the functions. The original function, f of x, call this the parent function, x squared. F of x equals x squared. Looks like they added 1, so they shifted it to the left 1 and also down 2. So whatever this graph looks like, the new one is shifted to the right 1 and down 2. I'm sorry, to the left 1 and down 2. Let's have a look here on Desmos. Alright, there's f of x, x squared. See that? And then we're going to shift it down 2 to the left 1. Boom. There we go. Exact same function. And that's the beauty. Desmos allows you to look at those transformations very quickly and easily. Thank you for watching. I hope this helped.